Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is L'Hospital's rule and its indeterminate forms. I'm going to show you two examples. We have seen many examples of this type in our previous videos. In the first limit, if we plugged in x is equal to 4, we would get 0 over 0. Am I right? 4 square is 16, 16 minus 16 is 0 in the numerator. Same way, 4 minus 4 is 0 in the denominator. And in the second limit, if we plugged in infinity, we would get infinity in the top row and minus infinity in the bottom row, in the numerator and denominator. Please recall that as x goes to infinity, a polynomial will behave in the same fashion that its largest power behaves. Am I right? So both of these are called indeterminate forms. 0 over 0, infinity over negative infinity. In both of these cases, there are competing interests or rules and it's not clear which will win out. So, in the case of 0 over 0, we typically think of a fraction that has a numerator of 0 as being 0. However, we also tend to think of fractions in which the denominator is going to 0 in the limit, as infinity or might not exist at all. Likewise, we tend to think of a fraction in which the numerator and denominator are the same as 1. So, which will win out? Or will neither win out and they all cancel out and the limit will reach some other value? Okay, that is what we are going to see in this topic. In the case of infinity over negative infinity, we have a similar set of problems. If the numerator of a fraction is going to infinity, we tend to think that of the whole fraction is going to infinity. Am I right? If the numerator is infinity, the whole fraction will be infinity. Also, if the denominator is going to infinity in the limit, we tend to think of a fraction as going to 0. We also have the case of a fraction in which the numerator and denominator are the same. It is just like ignoring the minus sign, infinity over infinity. And so we might get negative 1. Am I right? Because if you're dividing the same thing by itself, it will be equal to 1. So again, it's not clear which of these will win out. In any of them will win out. So with the second limit, there is a further problem that infinity is not really a number. Do you all agree with me? And so we really should not even treat it like a number. Much of the time, it simply won't behave as we would expect it to if it was a number. So to look a little more into this, let us do the types of infinity in our next video. Now this is the problem with indeterminate forms. It is just not clear what is happening in the limit. There are other types of indeterminate form as well. Let me list it out. So here are the list of the indeterminate forms. Please have a glance over this. So these all have competing interests or rules that tell us what should happen, and it is just not clear which, if any of the interest or rule will win out. So in this video, we are going to check how to deal with these kinds of limits. So far, we just had the introduction and we have seen the types of the indeterminate forms. As I already pointed out, we do know how to deal with some kinds of indeterminate forms already for the two limits with the examples I just showed. Okay, let me show it for you. I have taken the first example. First, I'm going to use the formula and factorize the numerator, and I will cancel out the common factor if possible. Here is a common factor, I can cancel this out. So in this case, if we simply factored and cancelled and took the limit, we will get 4 plus 4 is equal to 8. Now let us do the second example in the same way. Here in this case, I'm going to take the common factor out. I just wanted to eliminate this x square and x square. Because if I plug in the x value, the limit directly, I'll get infinity. I want to avoid that situation. So I'm going to take this as a common factor out and I'm going to rewrite this. So let's see what is going to happen. Do you see this step? Let me cancel out the common factors out. So we will be left over with 4 minus 5x in the numerator and 1 over x square minus 3 in the denominator. We are doing all these before we apply the limit. So if you plug in the limit here, then you'll get 4 over negative 3, which is equal to negative 4 over 3. So in this second example, we factored out an x square from both the numerator and denominator, and then we took the limit. Please notice as well that none of the competing interest or rules in these cases won out. So that is often the case. So we can deal with some of these. However, let me show you two more examples. What about the following two limits? Please have a glance over these two examples. Limit x tends to 0. If you apply this limit, sin 0 divided by 0, this would become a 0 over 0 indeterminate form. But we can't factor this one as we did the previous two examples. Same way, if you look at this example and apply the limit e raised to infinity over infinity the whole square, which is nothing but infinity over infinity indeterminate form. But we can't just factor an x square out of the numerator. Am I right? So nothing that we have got in our bag of tricks will work with these two limits. So this is where the subject of this video comes into play, which is nothing but L'Hospital's rule. Okay, let me list out. So here is the L'Hospital's rules. Suppose that we have one of the following two cases: 0 over 0 or plus or minus infinity over plus or minus infinity, where a can be any real number. This a, it can be any real number, infinity or negative infinity. So in these cases we have limit x tends to a f of x divided by g of x, which is equal to limit x tends to a f dash of x over g dash of x, provided that the latter limit exists. So L'Hospital's rule tells us that if we have an indeterminate form 0 over 0 or plus or minus infinity over plus or minus infinity, it can be of any sign. All we need to do is differentiate the numerator and differentiate the denominator and then take the limit. So before proceeding with the examples, let me address the spelling of L'Hospital. The more modern spelling is L'Hospital. However, when I first learned calculus in my from my teacher, I used this spelling that I use in this video. And the first textbook I taught, I was in the video, I was using this form, this spelling. So both will be considered as the correct spelling. So the spelling that I have used here is an acceptable spelling of his name. Okay. And because I'm using the spelling it as L'Hospitals, that is the spelling that I'm going to use in this video too. Okay, let's work out some examples. Here are the set of examples. We are supposed to evaluate each of the following limits. So we have already established that this is a 0 over 0 indeterminate form. So let's just apply L'Hospital's rule. We are going to use this. You can note down this example as a formula too. So according to the rule, I told you to find the first derivative of the numerator and denominator. So this would become cos x and the denominator would become 1. Am I right? After that, we can apply the limit. So after differentiation, you have to apply the limit. So cos 0 will become 1 and there is no x in the denominator. So it is obviously 1. 1 divided by 1 is equal to 1. L'Hospital rule help us to avoid the indeterminate form where we get confused regarding the answer. So by applying this rule, we can differentiate the numerator and denominator and then apply the limit so that we can avoid that critical situation and get a solution. Are you clear with this example number 1? Okay, let's do the B part. Please look at this part. 5t raised to 4 minus 4t square minus 1. If you apply the limit, you will get 5 minus 4 minus 1. So that will make 0. So even if you apply the limit in the denominator, you will get 10 minus 1 minus 9, which will also be equal to 0. So in this case, we also have a 0 over 0 indeterminate form. And if we are really good at factoring, we could factor the numerator and denominator. And then we can also simplify and take the limit. However, that's going to be more work than just using the L'Hospital's rule. So I'm going to do this one. I'm going to apply the L'Hospital rule now. The L'Hospital's rule says that you have to find the derivative of the numerator and first derivative of the denominator. So by doing so, we will get. Are you clear with the step? Now this is the step where we are going to apply the limit. So replace all t's by 1 and then we will get, this would become negative 3 over 7. Hope you're clear with part B. Okay, now let us move on to part C of this example. This was the other limit that we started off looking at, and we know that this is of the indeterminate form infinity over infinity. So let's apply L'Hopital rule. According to the rule, we are going to find the first derivative of the numerator and denominator separately. Now we have a small problem. This new limit is also the infinity over infinity indeterminate form. However, it is not really a problem. We know how to deal with these kinds of limits. So we are going to apply the L'Hospital's rule again. So e raised to x in the numerator and 2 in the denominator. So that would become an infinity. Sometimes we will need to apply L'Hospital's rules more than once until we get an answer. This is all about L'Hospital's rule and its application. In case if you have any query regarding this video, you can let me know. See you in the next video. Have a great